Hello, my name is Jorge Dias and I'm a master student from the University of Aveiro in Portugal. I'm here to present you with some results from my dissertation titled Sediment Bypassing at the Mondego River Tidal Head Delta based on a sediment budget analysis. The overall objective is to determine sand bypassing based on a sediment budget analysis, where the volumetric evolution of the delta and the adjacent beaches is calculated from a series of bathymetric and topographic maps. This work is ongoing, and in this presentation we will describe you with the methodology and results in terms of delta volume change using maps from 2018 and 2019. Our study area is located in the western coast of Portugal and is exposed to a high wave climate with main direction from the northwest. This induces southward littoral sediment transport of about 1.1 million cubic meters per year, of which 0.4 million cubic meters per year is trapped at the updrift beach adjacent to the inlet. Esri's ArcGIS 10.7 software was chosen for our work, and data from 2018 and 2019 was examined, while data analysis from 2014 to 2017 is ongoing. 3 sectors were defined as main transport pathways and accumulation areas across the inlet: the updrift and downdrift complexes. There are regions with rectilinear longshore breaker sandbars, and the outer shoal with lobate bars resulting from the interaction of the ebb tidal flows with the waves. Delta volume is calculated by constructing an idealized reference surface where the bathymetry doesn't have the delta, and comparing it to the digital elevation models. For the sediment budget analysis, we consider the following sediment transport path, starting north at the updrift beach, moving on to the updrift complex, the outer shoal, the downdrift complex, and the downdrift beach. For each morphological element, this equation is applied, where V is the volume eroded or accreted in each morphological element. Here we can see the various boundaries chosen for the morphological elements in 2018 on the left and 2019 on the right. Depth values are in meters and the reference level is the hydrographic zero. I will highlight the difference between the outer shoal seen here in red, where we can find a well-defined lobate bar in 2018 that is reduced in 2019. Next, we have maps of the deltas for 2018 and 2019, along with a table with the calculated volumes for each morphological element and the delta. We found that the updrift lateral bar was reduced from 2018 to 2019, while delta volume decreased approximately 13% from 3.62 to 3.15 million cubic meters. Bathymetric profiles were then taken in a northeast-southwest direction in order to cross the previously defined outer shoal location. They confirmed that there was a smaller amount of sediment in 2019, as there is a 1 meter elevation difference between the two. Volumetric changes were then calculated through the use of the cut fill tool. We can see that there was a loss of sediment in the updrift complex and the outer shoal, while the downdrift complex showed a gain of sediment. The deficit of material in the outer shoal is possibly explained by the dredging of the area just before data acquisition. Records show that 120,000 cubic meters of sand were removed around a month before this acquisition. This loss of material also indicates an accumulation rate of approximately 100,000 cubic meters per year, most of it removed by dredging. So in conclusion, the updrift lateral bar was reduced from 2018 to 2019, while the delta volume decreased approximately 13%. The outer shoal lost 20,000 cubic meters of sand, and dredging was responsible for the removal of 120,000 cubic meters of material, so the accumulation rate is 100,000 cubic meters per year since 2018 at this location. The estimated volume of bypass sediment to the downdrift beach is approximately 134,000 cubic meters per year. So this was our presentation. Thank you for your time.